Good morning, dear students. Now, in today's lecture, we will continue our last lecture of method number 2. There are too many numericals which are included in our textbook, and the last session is here. So, we will solve first of all exercise number 2.48 numerical. Again, dear students, I will repeat my instruction that open your textbook and just see in exercise number 2.48. Exercise 2.48. Okay, is here. Now, the question is, in astronomical observations, signals observed from the distant stars are generally weak. Observation for astronomical observation में जो स्टार में से जो लाइट इमिट हो रही है वो वीक है. If the photon detector receives a total of 3.15 into 10 raised to minus 18 joule from the radiations of 600 nanometers. So the wavelength is given, it is 600 nanometer. So we will convert this into meter. 600 into 10 raised to minus 9. We have to find number of photons received by the detector. Very simple. This type of numericals we have studied third time. The first about 100 watt, second one was 25 watt, and the third one directly energy is given. It is 3.15 into 10 raised to minus 18 joule. Okay, so first of all we will find E is equal to hc by lambda 6.626 into 10 raised to minus 34. 3 into 10 raised to 8 divided by 600 into 10 raised to minus 9. Okay, now 10 raised to minus 9, 10 raised to plus 9, ये सब कुछ आपको यहाँ पर सॉल्व करना पड़ेगा. ये आप सॉल्व करेंगे? I think so कि इसका जो आंसर रहने वाला है वो 3.31 into 10 raised to minus 19 जूल रहेगा. आप सबको ये सॉल्व करना है. आंसर ये आ रहा है कि नहीं आ रहा है? Just tell this answer. Now, number of photons 3.31 into 10 raised to minus 19 joule is equal to 1 photon. Then 3.15 into 10 raised to minus 18 joule is equal to how much? The answer 3.15 into 10 raised to minus 18 divided by 3.31 into 10 raised to minus 19. Solution is the answer of number of photons which is obtained by the radiation from astronomical process. This is exercise 2.48. Now, exercise 2.49 is here. Okay, what is in 2.49? Lifetimes of the molecules in the excited states are often measured by using pulsed radiation. Source of duration nearly in the nanosecond range. जब जहां पर वैल्यू आती है ना तभी हमें थोड़ा सोचना है क्या कर रहे हैं ये. तभी यहाँ पर ऐसा चल रहा है कि कोई मॉलिक्यूल अपनी एक्साइटेड स्टेट में है और वो रेडिएशन नैनोसेकंड में इमिट कर रहा है. If the radiation source has the duration 2 nanosecond, the number of photons emitted 2.5 into 10 raised to 15. Calculate the energy of source. Students, just see. अगर यहाँ पर हमें टाइम दिया हुआ है वो भी नैनोसेकंड में, तो अगर हम टाइम का इनवर्स करते हैं तो हमें फ्रीक्वेंसी मिलती है. क्या करना है? टाइम का इनवर्स. टाइम का इनवर्स होता है तो हमें फ्रीक्वेंसी मिलती है। तो देखिए यहाँ पर फ्रीक्वेंसी न्यू फाइंड करने के लिए I will use this formula nu is equal to 1 upon t. The time is given, it is in nanosecond. So if we will convert nanosecond into second, it is 1 by 2 into 10 raised to minus 9. 1 by 2 0.5 into 10 raised to 9. So 5 into 10 raised to 8 second inverse is our frequency. Now we have to calculate energy. We know that E is equal to NH nu y. N is here because number of photons is given in numerical. So N is here. The number of photons are 2.5 into 10 raised to 15, 6.626 into 10 raised to minus 34. 5 into 10 raised to 8. Now you all have to solve this calculation. This is the answer of exercise number 2.49 and the answer is given behind the textbook. Sorry, behind the last page of the textbook. So you have to see the answer. You have to verify your answer with solution. Okay. So this is exercise number 2.49. Okay. Let's go in exercise number 2.50 and 2.46 also here. Exercise 2.50. Okay, now just see about 2.50. The longest wavelength doublet absorption transition is observed. डबलेट का मतलब क्या होता है? देखिए जब वेवलेंथ यहाँ पर है इमिट हो रही है वो 589 और 589.6 नैनोमीटर। जब दो वेवलेंथ एक साथ मिलती है उसे कहते हैं डबलेट। मोनोक्रोमेटिक लाइट होती है ना वो सिंगलेट इमिट करती है। ये टू डिफरेंट वेवलेंथ साथ में होती है उसको डबलेट बोलते हैं। The longest wavelength doublet absorption transition is observed 589 and 589.6 nanometer. Calculate the frequency of each transition. Very simple. If we have wavelength, then we can easily find frequency. So the first wavelength is here, 589 nanometer. That means 589 into 10 raised to minus 9 meter. At that time we have to find nu 1. So nu 1 is equal to C by lambda 3 into 10 raised to 8. 589 into 10 raised to minus 9. The answer is here about the nu 1. Okay, then lambda 2. 589.6 nanometer, 589.6 into 10 raised to minus 9 meter. We have to find nu 2. Nu 2 is equal to C upon lambda 2, 3 into 10 raised to 8 upon 589.6 into 10 raised to minus 9. You have to give the answer about the nu 1 and nu 2. Okay, this is our frequency and the question is not ending. The further details is given that calculate the energy difference of this different wavelength. We have to calculate energy difference. If we have nu, then we will find, just see, energy difference delta E is equal to E2 minus E1. E2 minus E1 into H nu 2. E1 H nu 1. H is a constant, so we cannot calculate the difference of H. Difference in H1, H2, that is not counted because it is constant. So H will come here nu 2 minus nu 1 and 6.626 into 10 raised to minus 34 in bracket nu 2 minus nu 1. The value which you all have obtained from this step, nu 1, nu 2, you have to write this step, nu 2 minus nu 1. But when you will go through in a difference mode, then you have to common the values, you have to common the difference values, then you will find the right answer. So this is delta E2 minus E1. Exercise 2.50 is over and out. Then we will see exercise number 2.46. Exercise 2.46. What is it 2.46? Now just we will see this important point. What is it 2.46? Okay, very good example again. Nitrogen laser light produce a radiation at a wavelength of 337.1 nanometer. So lambda is equal to 337.1 nanometer. 337.1 into 10 raised to minus 9 meter. Before starting this numerical, first of all, I will watch on the board. Okay, now I have to change direction. Okay, so lambda 337.1 into 10 raised to minus 9 meter is our lambda. Then number of photons 5.6 into 10 raised to 24. Photon is here and we have to calculate the energy. So the formula is simple. E is equal to mhc by lambda, because we have the value of lambda. Now we will put all these values 6.022 into 10 raised to 23 into Planck constant 6.626 10 raised to minus 34 into C 3 into 10 raised to 8 upon lambda 337.1 into 10 raised to minus 9. So here it's a mistake. We cannot take 6.022 because number of photon is given. So we have to put 5.6 into 10 raised to 24. Students, correct my mistake on that point. Not 6.022, but we have to take 5.6 into 10 raised to 24 because the value of number of photon is given in numerical. That's why we have to correct this mistake. NC by lambda, correct this mistake and put all the values in this equation. Finally, you will get the answer of exercise 2.46 and verify your answer with the final answers which is given in last stage of our textbook. Okay, this is exercise number 2.46 and now the method number 2 is over and out. खत्म हो रही है मेथड 2. बट देखिए स्टूडेंट्स, अगर नीट और जेडब्ल्यू में कोई भी एमसीक्यू इसमें से निकलेगा तो मैं गारंटी के साथ बोल सकता हूं आपको कोई भी प्रॉब्लम नहीं आएगा. चाहे आप एररलेस सोल्व कर लें, चाहे आप एचसी वर्मा सोल्व कर लें, जो भी आपको सोल्व करना है वो कर सकते हैं. बट इसके बाहर कुछ नहीं निकलेगा, ये मैं गारंटी के साथ बोलता हूं. तो आप सबको इस मेथड को कांस्टेंट रिवाइज करना है, कुछ भी दिक्कत नहीं आएगी. मैं आपके साथ खड़ा हूं. ठीक है, कितने ही एमसीक्यू हमने प्रैक्टिस कर ली है मेथड नंबर 2 में और लास्ट में आगे हम बढ़ रहे हैं मेथड नंबर 3. मेथड नंबर 3 is here and here are the formulas of method number 3. Work function W0 is equal to h nu minus h nu 0. The second formula about h nu minus h nu 0 is equal to 1/2 mv square. This is about the kinetic energy. Same as work function W0 is equal to 1/2 mv square, again is equal to kinetic energy. So these are the different formulas for method number 3, and I will give you an important work about this important point. According to method number 3, you all have to calculate problem number 2.9 in example. Exercise 2.9, which I have wrote in front of the board. Right now you cannot see this, but when you see the full board, then you will got it. So 2.9, 2.12 and 2.53 स्टूडेंट्स, ये सब आपको इस मेथड से सोल्व करने की कोशिश करनी है। पर नेक्स्ट लेक्चर में कल ही मैं ये मेथड नंबर 3 के सभी न्यूमेरिकल्स आपको सोल्व करवाऊंगा। बट आपको वो न्यूमेरिकल मुझे सेंड करने की जरूरत नहीं है। कल आप वेरीफाई अपने आप ही कर लीजिएगा कि आपके आंसर राइट है या रॉन्ग, और आपके आंसर को वेरीफाई करने के लिए आपके टेक्स्ट बुक में लास्ट पेजेस में दिए हुए सॉल्यूशंस आंसर्स वेरीफाई करने हैं। अगर आपके आंसर उससे मैच होता है देन यू आर राइट, बट इफ योर आंसर्स आर रॉन्ग देन आई विल सॉल्व दिस इन माय नेक्स्ट लेक्चर, देन यू कैन वेरीफाई दिस। ओके, सो आज के लेक्चर के लिए इतना ही हम सॉल्यूशन रख रहे हैं। अच्छी तरीके से आपने लेक्चर एंजॉय किया होगा, सब कुछ मेथड आपको समझ में आई होगी। मैंने अपनी लेवल बेस्ट ट्राई आप सबको समझाने के लिए इस मेथड में की हुई है। ओके, सो थैंक यू ऑल फॉर टुडेज लेक्चर।